we're using such a simple proportion here that, just to recap, we had $2 for 5 apples, so we were saying, how much is it for 10 apples? And again, I'm not trying to insult your intelligence here, but just to show you, you use proportional reasoning all the time. Any question like that, anytime you have something like that and you say, well, that's twice as much, that's got to be twice as much. That's the logic and the reasoning we're going to use when we set up a proportion. This is a proportion. You've likely used proportions before and written proportions before. It's saying two rates. These are actually two rates because the units are different. You're saying that two rates are equal. Except there's a missing number here, right? Now I put a question mark there. Probably now that you're in high school, the thing you're going to want to use is not a question mark or a box like you used in grade 1. What are you going to put for a missing number, an unknown number? What are you going to put? A letter of some sort. What should we put here? X for price, because the word price starts with X? No. X is fine. X seems to be the one that mathematicians use all the time. You can use whatever. The logic you're using then is you're saying this is times 2. So this, what has to be true about that? Times 2. That's what a proportion is. Okay? If we did the same thing now and said, well, we know it's... If we did the same thing and said, well, we know it's $2 for 5 apples, how much would it be for 60 apples? And we're going to call this something else here. Let's call it Y. I don't know. Use a different letter this time. How can you figure that out? How can you figure out how much it's going to be? What can you do? Yeah, 60 divided by 5. You're trying to figure out what you're multiplying it by, what the multiplier is, right? If you do 60 divided by 5, how many times more is that? What's the ratio there? It's 12, right? This is times 12. If you divide 60 divided by 5, you figure out it's 12 times more. So what do you got to do with this? Times it by 12, right? You've got to times that by 12. That's what you're using when you use proportional reasoning when you think about it. The first thing I showed you with the apples, that's what you did in your head without even anybody telling you to, right? So don't look at this and say, I totally don't get it because you're drawing arrows in 2 different colors and all this crazy stuff. It's exactly what you do already intuitively if someone gives you a situation like that. So if I take $2 multiplied by 12, I know it's going to be $24. Even if it's weird numbers, okay, we'll do one with weird numbers here. Let's say now we're going to have a different thing missing. We're going to do this. It's $2 for 5 apples. And I have $31.50 in my pocket. What about if it's something weird like this, like how many apples could you get for $31.50? That one you can't necessarily do in your head just by thinking about the numbers, right? But if this is B, I don't know what B is for, but let's say we're trying to figure out that unknown number there. B is for, that would be an interesting proportion question, but you think about it exactly the same way. You got to figure out this though. What's the ratio there between those two so you can do the same ratio between those two? How could you figure out the ratio between the top two numbers? Some of you are grabbing a calculator, which is a good idea. What do you get?
You can divide 31 by 5 by 2.
Absolutely. Divide that by 2 and what do you get? I think you get, what do you get? 15.75. All right. So this is times 15.75. So what do I got to do at the bottom? Times by that, right? Now you're going to get a weird number there. Somebody tell me what that weird number is. Not that I should be prejudiced against numbers that aren't whole numbers, but what number do you get there? I just sort of noticed that some of you aren't writing this down either, which is not a good strategy. What is it? 78.75. You got to get 78 and 3/4 apples. Obviously, you can't buy 3/4 of an apple, but that's the number, right? You could. That's the number, right? Okay. Do you think you know how to use a proportion? This is the key, is writing the proportion. Did you notice that on the fraction that I wrote on the top of both of them is dollars, and on the bottom of both of them was apples? Would it be okay if I did it the other way around with apples on top and dollars on the bottom? It would, as long as it's the same on both, right? It's if I switched one of them around. If I had dollars, apples, and then apples, dollars, that's no good. It's got to be the same both ways. There's different ways you could do this. This is called using a proportion. In the textbook, it talks about two different ways of solving proportion questions. One is using a proportion. There's another thing in there that says method 2. Method 2. Actually, I think it's method 1, but method 2 was this. You could also use a unit rate, now that you know what unit rates are. We could have figured that out this way. So you should write down method 2, and we'll write it down here. If it's $2, we'll do the first one because we'll do the second one. It's $2 for 5 apples, right? How much are 60 apples, right? That's what we want. That's the one we're doing. The one that we figured out right over here, right? This one? If you're going to use a unit rate is what unit rate could we figure out here from the facts you're given? What could you figure out? What do you think? Anybody? Well, you know this fact here, right? How could you get a unit rate out of that? Be brave and say something, somebody.
You divide it.
Yeah, what would you divide?
2 by 5.
Rate per apple. You could work out and say, if it's $2 for 5 apples, that gives me, if I divide 2 divided by 5, what do I get? Some number? What's 2 divided by 5? 0 point something. What is it? 0.4. And what are the units on this rate here? If I divide dollars by apples, dollars per apple, right? $0.4 per apple. What that means is each apple is $0.4, 40 cents, right? If you know what the unit rate is, and you know you're buying 60 apples, how do you figure out how much 60 apples cost? This is the rate per apple, right? Rate per apple. And then so you got 60 apples times 0.4. Each one costs $0.4, rate per apple. What does that give me? What does it give me? Well, if you figure out the rate for each apple and you know how many apples, what do you do with those two numbers? You multiply them, right? You multiply them. If you multiply them, you're going to get $24, right? Okay, $24. It's the same thing as you get over there, but this is a different approach. It's working out a unit rate first. So when you look in your study guide, in your textbook, it says method 1, method 2. You need to be able to do both of those things. You need to be able to use a unit rate, and you need to be able to use a proportion. Okay? Is that clear? Sort of?
Yes.
Good. So then if we look down below at your study guide here, I gave you some ideas about what a proportion is. I gave you a huge space to write something down there. I would like you to put your own examples. I used apples and dollars. You could make up your own. It's really easy, right? Cans of paint to paint a room, anything, right? You can think of anything where you might say it takes 1 can to paint 100 square meters, so how much is it going to take to paint 600 square meters or whatever, anything like that, right? You were making a recipe and it called for 2 cups of flour to make 24 muffins. How much would it take to make this or whatever, right? Any of those things could be a proportional reasoning type of situation. When you're working through these things, again, I really want you to realize that these are in the textbook, right? I tried to put a little note here. read page 64 for help with this example. You should be using the textbook, just to, even if it's just to check your work as you're working through, right? Or if you're stuck or whatever. Here's the two methods that you need to be able to do, right? You need to be able to use a unit rate, and you need to be able to use a proportion. A unit rate is figuring out something like it's this many dollars per whatever. In this situation, it's something maybe you're not familiar with, which is buying electricity for your house. Did you know it costs money? It costs money. It doesn't cost very much for one unit that you get it in. It comes in, you measure it in kilowatt hours. That's what that kWh stands for, kilowatt hours.
Is that equal to real hours?
This is using a certain amount of electricity for an hour. That's what 1 kilowatt hour is. Not to get into the science of it, of what a kilowatt hour is, but these are units of electrical energy. And these are obviously units of money. Okay? You can work it out. You can come up with a rate per kilowatt hour, or you can come up with a proportion. I think some of you are going to like the proportion way of doing it and saying, if that's true, then what about this? You should probably start by saying dollars, kilowatt hours. So it says, or cents, I guess it's in cents, isn't it? It's 11.58 cents for 2 kilowatt hours. And then on the proportion on the other side, or in the ratio that you write on the other side, or the rate you write on the other side, it says, how much is it for 30 kilowatt hours? And you can put a question mark or a variable or whatever you want over there. And again, how are you solving this if you're using a proportion? You should probably just draw some nice little arrows to show what you're doing. You could, once you write the proportion, it's easy to see how to figure out the number. The unit rate way of doing it is to say, if it's 11.58 cents per 2 kilowatt hours, that's the same as, and you divide it and say cents per kilowatt hour, 1 kilowatt hour, right? And then you take that unit rate and say, well, if I have to buy 30 of them, how much is it going to cost? Make sure you can do both those methods. All right? Can you get working on that if you have not